Hi, this is Janakreddy Dubbaka, Relative Motion, lecture number 3. In this video, we are going to discuss relative motion in 2 dimension. This is the part 1. So here in 1 dimension motion, velocity of A with respect to B, that is VA bar minus VB bar. In 1 dimensional motion means either they are moving in same direction or in opposite direction. For example, if they are moving in same direction, this is VA bar and this is VB bar. Therefore, velocity of A with respect to B, that is VA minus VB. If they are moving in opposite direction, one is VA, another one is VB, then velocity of A with respect to B, that is equal to VA plus VB. But in 2 dimension motion, they are not moving in same direction or opposite direction. There is some angle between their velocities. For example, here is VA bar and this one is VB bar and theta is the angle between them. Then velocity of A with respect to B is equal to VA bar minus VB bar. The magnitude of relative velocity, that is equal to square root of VA square plus VB square minus 2 VA VB cos theta. This is the magnitude of relative velocity in 2 dimensional motion. So this concept are going to use in this video. If there is a collision takes place between the particles, what is the condition for collision? If they are not collide, what is the shortest distance between the two particles? See here are two particles. This is particle 1 and particle 2. Its position vector is r1 bar and the particle 2 position vector is r2 bar. And particle 1 is moving with velocity v1 bar and 2 is moving with velocity v2 bar. So this diagram are velocities and the position vectors are represented with respect to ground. For example, with respect to particle 1, with respect to particle 1 means the observer is sit on the particle 1, means observer 1 is at rest. Therefore, this is the position vector of 2 with respect to 1, that is r21 bar. And velocity of 2 with respect to 1, this is v21 bar. Therefore, r21 bar is equal to r2 bar minus r1 bar and v21 bar is equal to v2 bar minus v1 bar. Here, if there is a collision between 1 and 2, then v21 bar should opposite to r21 bar. Here, there should be some collision between 1 and 2. This only possible when the velocity vector of 2 with respect to 1 should be opposite to the position vector, means their unit vectors are in opposite direction. Therefore, unit vector of velocity, that is v21 bar by modulus of v21 bar, this should be opposite to the unit vector of the position vector. Therefore, r21 bar by modulus of r21 bar. This we can write down. v21 bar means v2 bar minus v1 bar and modulus of v2 bar minus v1 bar. This is minus of r2 bar minus r1 bar by r2 bar minus r1 bar. See, this is the condition for collision. So very, very important. If there is a collision between two particles, the condition should be the velocity of the one particle with respect to other particle should be opposite to the position vector of 1 with respect to 2 or 2 with respect to 1. Means their unit vectors and velocity unit vector and position unit vectors are opposite in direction. Therefore, this is velocity vector and this is the position vector unit vector. Minus sign is they are in opposite direction. This is the condition for collision. For example, if they are not collide, what is the shortest distance between the two particles? See here, the time after which collision will occur, time is equal to distance by velocity, the position vector 2 with respect to 1 by velocity of 2 with respect to 1. This is after which the collision will occur. For example, if they do not collide means velocity vector is not in the direction of position vector. Therefore, the particle 2 with respect to 1 is moving in this direction, and this is the position vector of 2 with respect to 1. The two are not in same path along the same line. In that case, there is no collision. If there is no collision, what is the shortest distance between the two particles? Therefore, if you draw the one perpendicular from V to 1 bar onto 1, this is called D minimum. This is minimum distance between the two particles. For example, if here this is the angle theta given, therefore from this triangle, sin theta is equal to opposite side by hypotenuse. This is the hypotenuse. Therefore, D minimum by modulus of R2 1 bar. Therefore, D minimum is equal to position vector modulus into sin theta. This is the minimum distance between the particles when they are not collide. Here are some problems. An object A and B both have speed 10 meter per second. A is moving towards east while B is moving towards north, starting from the same point as shown. Find the velocity of A relative to B. See, this is velocity of A moving towards east, and this is velocity of B moving towards north. Therefore, velocity of A with respect to B, that is equal to velocity of A bar minus velocity of B bar. Therefore, modulus of velocity of A with respect to B is equal to square root of VA square plus VB square minus 2VA VB cos theta. Here theta is 90 degrees, therefore cos 90 is 0. Therefore, velocity of A with respect to B, that is equal to VA square plus VB square, that becomes square root of 10 square plus 10 square. This becomes 10 root 2 meter per second. This is velocity of A with respect to B, its magnitude. For example, what is the direction? Therefore, here velocity of A with respect to B means VA bar minus VB bar. Means for vector VA bar, I have to add a minus VB bar. So here, draw the vector VA. This is VA bar. Minus VB bar means opposite to this one. But in vector addition, we have to add a head and tail method. Therefore, this should be added to minus of this VB should be added to VA. Therefore, here this should be minus VB bar. Now join the tail of the first vector to head of the second vector. Here this is velocity of A with respect to B. Now this is the direction. Means for example, this is east and this one is north. Here is south. This one is west. Therefore, here this is velocity of A with respect to B. Then its direction can be find out angle made by horizontal, or also we can find out the angle with the vertical. This is the direction of the velocity of one vector with respect to another. Another problem, two particles A and B are projected in air. A is thrown with a speed 30 meter per second, B with a speed of 40 meter per second as shown in the figure. What is the separation between them after 1 second? So here both are thrown into the air. Therefore, acceleration of A is equal to G and acceleration of B also G. Therefore, acceleration of A with respect to B, that is acceleration of A bar minus acceleration of B bar. This is equal to 0, G minus G, that is equal to 0. Therefore, acceleration is 0. When acceleration 0 means velocity is constant. Therefore, velocity of A with respect to B is equal to VA bar minus VB bar. Its magnitude is equal to, here VA bar and VB bar, the angle between them is this angle is 90 degrees. Therefore, here this becomes square root of VA square plus VB square, that is one is 30 square, another one is 40 square, therefore this becomes 50. But we have to find out the separation between them after 1 second. Separation means relative separation, displacement of A with respect to B. Here it is a constant velocity, therefore distance is equal to velocity into time. Therefore velocity of A with respect to B into time. Velocity of A with respect to B is 50 and the time is given as 1 second. This becomes 50 meters. This is another problem. Two ships A and B are 10 kilometers apart on a line running south to north. Ship A farther north is streaming west at 20 km per hour and ship B is streaming north at 20 km per hour. What is their distance of closest approach and how long do they take to reach it? See here, ship A is farther north, it is moving towards west, and the ship B is moving towards north, and the distance between them is given as 10 kilometers. Here I am going to find out velocity of B with respect to A. With respect to A means A is at rest, means the velocity of A should be added to B but in opposite direction. See, velocity of A is towards west, that should be added to B towards east. Therefore here velocity of B is in this direction and the velocity of A is in this direction minus in this direction. Therefore velocity of B with respect to A should be in this direction. This is velocity of B with respect to A. Here both having same velocity, therefore this relative velocity direction should be bisecting this one x and y axis. Therefore here this angle is 45 degrees and this angle is 45 degrees. If you draw the perpendicular from A to this line, therefore this is the nothing but closest approach. This we have to find out this distance and what is the time taken from here to here. This is the time taken to reach that minimum closest approach. First we have to find out velocity of B with respect to A. Velocity of B with respect to A. The two are perpendicular to each other. Therefore, VA square plus VB square. Therefore, velocity of B with respect to A is equal to both are 20. Therefore, this becomes 20 root 2 kilometer per hour. This is velocity of B with respect to A. See here from this triangle, then sine theta is equal to opposite side is that is D minimum by hypotenuse AB. Therefore, sine theta means this is sine 45 degrees by D minimum, AB is 10. Therefore, D minimum is equal to 10 into sine 45 1 by root 2. Therefore, this becomes 5 root 2 kilometers. This is the closest approach. Then what is the time taken means the time taken from here to here. In this direction velocity is VBA. Therefore, here angle is 45 degrees. Therefore, this one both are same. Therefore, time is equal to here velocity of B with respect to A is equal to distance BC by time t. Therefore, here t is equal to BC by velocity of B with respect to A. BC also equal to this one 5 root 2 by VBA is 20 root 2. Therefore, root 2 it cancel. Therefore, 1 by 4 hour. Therefore, this is the time to reach the closest approach, and this is the closest distance between the two particles.